Hi, and welcome to the GibbsCAM 3-axis machining presentation. My name is Chris McBain, and I'm going to be your presenter today. As most of you probably know, GibbsCAM has been around for a long time. Gibbs has always taken great pride in developing powerful, easy-to-use software that's both flexible and productive. From consumer products all the way to energy, we here at Gibbs, we've helped thousands of companies succeed across many different industries. Whether it's basic milling, multi-axis machining, machine tool management, or cutting-edge multitask machine programming, Gibbs can make your job faster and easier. Today, we're just going to focus on one part of that, and that's going to be 3-axis programming. GibbsCAM has always been an industry leader in machining surfaces and solids. Now, every single seat of GibbsCAM 3D milling comes with the complete suite of 3-axis machining processes, all the legacy processes, plus the full range of advanced 3D machining solutions. I'm going to use the files you see here to show you the GibbsCAM 3D milling package and how it can really help you optimize your CNC investment and really blow by your competition. I'm going to start with some roughing routines and then cover the basic and more advanced approaches available to you for finishing. So let's go ahead and get started. Alright, so here's a part I wanted to use to show roughing. It's pretty straightforward, it's pretty basic. I'm going to show you a more advanced example right after this, but I wanted to use this just because it shows really well the difference in the different roughing strategies. So if we look here, we've got a 375 cutter. I'm going to use that to rough it out. And here is the advanced 3D machining. The surfacing, the old 3D, or I shouldn't say old, the legacy 3D surfacing, it doesn't have any roughing routines in it. It just has finishing. With the more advanced 3D, it has roughing routines. So let's go ahead and just drag that down, and I'm going to show you that right now. So here we can see that there's actually 3 different options for roughing: pocketing, pocketing with core detection, and then adaptive pocketing. I'm going to show you the difference between all those right now. All right, so pocketing, here's the nice thing with the solids. I'm just going to go ahead and click on that solid, hit pocketing, where I'm going to start, where I want my tool path to end, and what my step down is going to be. Let's say it's going to be 100 thousandths, and let's just go ahead and click do it. This is another thing with the advanced. We have this task manager up here, and what this does, this allows you to stop, pause, and restart tool paths. For instance, if I was to come here and just say by accident I put some crazy number in here and I say do it, I'm waiting, it's tessellating, it's doing this stuff. I've done this enough where I know, wait a minute, this is taking way too long. Passes calculation, this is crazy. I can actually click on this. So you know what, stop it, something's wrong. Check my tool path and say, oh, that's what it was. So let's go ahead and change that back, and let's go ahead and click redo. So just to optimize my screen, I'm actually running 2 monitors. I'm going to pull this onto my other monitor for the rest of the presentation. It is running throughout this whole presentation. It's just on the other screen so we can get a better look at the part, have a little bit more real estate here. So we can see what it did. You know, this is the traditional roughing routine. Let's look at the top view of this. We can see that it just took that outside, offset it, and then took those Z slices down. Let's look at a side view. Right? This is pretty basic, straightforward stuff. We've seen all this before. This is great. Now the problem is let's go ahead and simulate this. When we have a 3D part that has like a slant on it, like a taper, like this, you can see that as we step down, you end up with these huge steps. Now the problem with this is let's say I have this really great cutter. It can go down, let's say 375 went down 100,000. Let's say you can go down 200 thousandths of an inch to really get the most material out. But what we end up with is 200,000 steps here, and then we got to come back and we got to finish. And you know, how do you do that? I don't want to go ahead and do this whole tool path and cut air just to cut those things down. So this is where these other 2 approaches come in handy. So we're going to say pocketing with core detection. What this does is this allows you to do your Z step and then cut each one of those Z steps into a number of levels. So if we, right here it says wall cleanup control, number of levels 5. And so what it's going to do is say after and upward. So what it's going to do, it's going to cut using that 100,000 step all the way down, and then it's going to move up and cut each one of those steps each by a 5th and finish it up. So let's go ahead and redo that. And there we go. So it looks like there's a lot more toolpaths, which there is, but the best way to look at this is through machine simulation. But one thing I wanted to point out, this is a little shortcut in Gibbs that some people may know, may not. When you're doing 3D machining, what I want to do is I want to contain this toolpath within this area. I don't want it to cut these corners yet. I'll just do that with a regular 2-axis. So what I can do is I can actually, let's go ahead and turn on edge detection. I'm going to extract those edges. Let's go ahead and hit do it. Let's close that out. So now when I select the model, I'm going to hold down the control key. I'm going to pick that, and it's automatically going to contain that toolpath inside of that line. There we go, just like that. So now, you know, that's really easy to make bounding geometry to define your 3-axis toolpaths. All you do is you just select the 3D geometry, whether it's a surface or a solid, and then the line geometry, and that'll automatically contain the toolpath. So let's go ahead, move this over just a little bit. Let's take a look at how this renders. So we can see it's stepping down. It goes all the way down in those 100,000 steps, and you see now it's coming up, and it's dividing each one of those steps by a fifth. Let's speed that up just a little bit so we can see it. See, it's making those, and it's just going around the profile. All of this stuff in the middle, it's already cut. It's not even bothering with. So you're optimizing that tool cutting by taking out as much material as possible and then coming back and doing a little bit of a cleanup and reducing those steps as it comes up. So this is a really efficient way to do this. So one thing that's relatively new, you know, 5-6 years, you know, in machining that's really new, is this engagement of the tool control, like really controlling how much material that tool is going to take off. We have volume mill that we offer as a solution for that. So let's say I wanted to do this, I wanted to rough this using that type of tool path. And let's go ahead and close this render out. And that is where adaptive pocketing comes in. So we're going to change this to adaptive pocketing. Now this is just a little bit different because here we have our main step in Z, that's 100 thou, and let's say our fine step, that's how little those steps are going to be, is going to be 20 thou. So if we go ahead and look at a top view of this, right, we can see that that's pretty traditional. So let's go ahead and redo this in the adaptive and see what we get. So there we go. So we can see that it's a lot longer of a tool path. If we look at a top view of this, though, we're going to be able to see in the simulation why it's different and why we're going to be able to run this much, much faster. You can see that it turns it all into circles and arcs. Let's speed it up. We get the idea. Instead of doing those really hard straight line cuts, you know, this is a lot easier on the tool, a lot easier on your machine, all that other stuff. So, and we can see that it's actually this one, it makes that long cut, it makes the deep cut, and then comes down and cleans it up. So this is going to be, you know, if you have a lot of material to remove on a 3D part, whether it's a surface or a solid, and you have some kind of taper on it, this is probably the fastest way to get the material out and be left with a pretty good model afterwards, like a part with not a lot of material left on it. There we go. We can see that it's going through and just machining those sides. There we go. Great. All right, so let's go ahead and we're going to take a look at a more advanced application of this. So let's say we have a part like this, and we want to I just want to rough out the inside of this. So I'm going to use this 1/2-inch cutter that I have, and let's go ahead and pull this down. And I'm just going to use pocketing for this. So let's just go ahead and pocket it. It's just for an example here. Let's go ahead. We're going to start it. I'm holding down my Alt key. I'm going to press that surface, and then my lower surface. We're going to stop right there. Remember, I just want to cut the inside of this, so I'm going to turn on edge selection. I'm going to double click on this edge, right mouse button click and say extract edges. Let's go ahead and do that. Let's turn off edge selection now. All right, so now I'm going to go ahead and click my model. I'm holding down the control key, double click on that, and I'm going to click do it. And there is the little progress bar that shows you how fast it's going. And there we go. So you can see that all of the surfaces and nooks and crannies and pockets and holes and slots and all other stuff in here, I don't have to go through and pick all of that. All I do is I pick the solid. I'm able to go ahead and make a tool path right on that solid. And with using the 3D, advanced 3D, I'm also able to do, you know, this pocketing with core detection so I can get smaller steps, and also that adaptive pocketing, which was roughing out using that limited tool engagement, toolpath strategy. All right, so that's roughing in 3D. So let's go ahead and look at some of the finishing routines. All right, so we're going to use this model to go over all of the, well, not all of, but some of the fundamentals of finishing in Gibbs using 3-axis. First, let's go ahead and talk about the legacy ones. I'm going to go ahead and make a tool here really quick. It's just going to be a really easy ball mill, say 1/4 inch. As far as a holder goes, I don't know, we'll get something that's pretty normal, say something like that. That looks good. All right, so let's go ahead and drop that tool down, just drag and drop. I'm going to drag and drop down this surfaces. So this is the legacy 3-axis machining stuff, and it's pretty good. It's great stuff. It's worked for years. It was really cutting edge and still does a really nice job. It's a little redundant, most of this stuff, because it's in the advanced stuff. One thing that's nice, and this is what I use this for, is this surface flow cut. If you want to just follow one surface and use the UV, which is the directions of the surface, the way it was created, to machine that particular surface or that set of surfaces, this is a really good solution. So what we can do is we can actually pick surface flow cut. Let's turn on surfaces. Just pick a couple of surfaces here. XY step over thou, that's fine. Let's go ahead and hit do it. And we can see that it just goes ahead and just creates a nice little curve there that does those surfaces. Now, you know, one thing to note is it doesn't take into account any of these surfaces down here. It's going to go, so you have to really be careful when you use this, because it's only looking at those surfaces that you pick. But you know, realistically, it'll give you a pretty nice finish. We can simulate this. It'll look a little wonky, but you guys can get the idea as it comes through and just kind of machines up through that one little surface here. It gives me a really nice finish. Zoom in on that. So nice little finish there. That's great. So not saying that never to use the old surfacing stuff. Like I said, it still has some really good viable options in there, but again, most of it's redundant except for that surface flow cut. So that being said, let's go ahead and switch to the advanced, and let's talk about some of the finishing options here. So let's go ahead and just toss that real quick. Okay, one thing I want to do. So one of the biggest problems that I had in the shop when I was machining these things, when I say these things, is 3-axis parts, is if I had bosses or holes in it like this. Really what I want is I want that tool path to just kind of flow over that surface and not have to worry about these holes. And in other software that I've used, I had to create surfaces or plugs or all this other stuff. I'm going to show you how easy this is in Gibbs. So what I can do is I'm going to open up my solids, and in my advanced solids palette, there's this thing called Unstitch Solid. So I'm going to go ahead and I'm going to pick these cylinders like so, and I'm going to click Unstitch. See? And it closes them up just like that. So I'm going to go ahead and do that again with these guys. Really easy. So the other thing I want to do is I kind of want to get rid of these fillets here. So I'm going to unstitch those real quick. All right, and last but not least, I'm going to go ahead and I'm going to fill in this middle part, because I don't want the tool to dip down. I don't mind it coming down in here. I'm probably going to go in there with a flat end mill anyhow, so you know, maybe I'll get some of that material out, but I don't want it to plunge all the way down to the bottom, so I'm just going to go ahead and stitch that up. Great. So one thing Gibbs does is when you stitch a hole like that, it creates a plug. So not only does it stitch that surface, but it also creates another surface, or another solid. That's that plug for that. What I did is I double clicked on it and put it in the body bag, which is a kind of a holding area, for those that you don't know, for solids. If I have multiple solids in a model, I can double click it, store it in the body bag. All right, so now this is just about ready to go ahead and machine. I'm going to clean this up just so I can see it a little bit better. I'm going to go ahead and turn off the stock up here, and I know where my 0 is, so I'm going to go ahead and turn off that too. All right, so I'm done with my surfacing, or my solids. Let's go ahead and go to our machining. All right. Let's go ahead and get this in a nice isometric view here. All right, so first thing we're going to talk about is lace cut. This is the first option in the surfaces tile also. This is a really straightforward cut. So I'm going to go ahead and make it just kind of a big step over so you can see what it's doing. I'm going to pick lace cut. Let's turn off surfaces and go ahead and click do it. There we go. So this is it's kind of your bread and butter when you're doing 3-axis. Those of you that's done 3-axis machining before, you probably used this a bajillion times. Let's go ahead and look at the top view of this, so just so we can all be on the same page of what it's doing. What it does is it takes this XY straight line step over. Now you can change that angle right here in cut angle if you want it to go on a 45 or something, but out of the box it does it at a 0-degree angle. It takes that and then it pushes it down and overlays it onto the model. This is an okay strategy. The problem is you know, when you start getting into more vertical walls, you end up with scallops, and a scallop is that little V-shaped groove, or I should say little mountain that's left in between the tool cuts. The bigger the step over is, the bigger your scallop is going to be. The smaller the scallop, the easier it is to finish. So this again is really the game that you play when you do 3-axis machining. Do you want a really small step over and have it be on the machine for a really long time? Or do you want to get it off the machine, give it to a guy to hand finish? So really that's the thing. So really, you know, you want to find a good in between, a good kind of medium that doesn't take too long in the machine, but it's not too hard for your guys to finish. So this one's gonna be kind of hard to finish because there's all of those scallops there. So let's see what other options we have here. Here's end curve flow. What this will do is this will actually create a tool path that averages out between two curves. So let's go ahead and create two curves here really quick. So I'm going to go ahead and I'm going to extract that edge. I'm going to zoom in and I'm going to extract that edge. All right. They do it. There we go. All right, so we're going to say end curve flow. And when we switch over to end curve flow, you can see that I have these two options down here, drive curves and trim curves. I'm going to use these as drive curves. So I'm going to say, let's go ahead and define the drive curves. I'm going to define that circle that I made up there, and then this guy right here. Oop, let me hold down the control key. There we go. Let's go ahead and click OK, and click the model and do it. Great, so now we can see here, let's go ahead and move it over, and let's look at a top view. We can see what it did. It actually started the outline, and then as it came in, it started averaging out into that circle. So it morphs that tool path in between those two shapes. For something like this, it's pretty great. It's a pretty good, legitimate tool path. You don't end up with too many horrible scallops here. You can see as it climbs down the wall, the reason I know this is see how the spacing changes? It's pretty close here, and as it comes down, it gets bigger. That's because of the way these tool paths project, the way that it's projecting down. You know, those are pretty easy to clean up sometimes. For instance, the next thing down is a curve project. I'm going to show you how to use that to clean up tool paths. Let's get this over so we can see it pretty good. All right, so we're going to do curve projection. So what this does is this takes a curve, a tool path along that curve, and projects it down onto a surface or a solid. I like using this to finish up edges, curves, like very specific parts of a model. If I need that part to be really good just in certain areas, let's say for instance just around this circle is kind of the seating area. That's where it's going to go ahead and interface with the next part. So I'm just going to go ahead and click that, click OK. And I'm going to go ahead and say, if I just hit yes right now, it would make one tool path that followed that circle around, come up, be done with it, great, all right, it's projected, awesome. What I want to do is I want to add some to either side of this to really clean up that surface. So I'm going to say, you know what, I want to offset this 10 times. Go ahead and click that model and hit do it. Fantastic. So we can see what it did. It actually took that tool path from that curve and then offset it 10 times in each direction. If we look at a side view of this, let's turn that not yellow anymore. We can see that it's following that curve up here, and then it kind of dips down into that feature down here. So we can actually see that it's following that. So it projects that tool path down onto the surface. One thing I wanted to show you guys though is, you know, so far we've been talking a lot about projecting down. So everything that I've shown you has been kind of in a top view, and it's projecting down onto the model. And as I said before, it's fine, except the problem is when you start getting more vertical or near vertical walls, you're really hoping that as it offsets, it's going to offset in a way that's going to be even and hit that wall, and it almost never is. It's always either a little shy or a little big, and you always end up with more material than you need, and to go to that finish pass is a little bit brutal. So what's the answer? So what are we going to do? So the next one here, let me show you, is contour. So as I was saying before, all of the stuff that we looked at projects it down. Let me show you what contour does really quick. So we can see here that the step over is kind of big. I should probably make this a little bit smaller. But if we look at the top view of this, we can see that it's not even. But when we look at a side view, it actually takes and steps it in an even Z step. So let's go ahead and make this a little bit smaller so we can get a better idea of what it's doing. There we go. So now we can see that if we zoom in here, see it's got that nice even Z step, Z height as it's going up, nice and even. So it actually splits the model that way and then lays that tool path around on the model. So this is really good for the sides, or for near vertical sides. Now the question is what do we do if we want both? There's a couple things to do. One, we can run two tool paths. One that does the projected down, whether it's a lace cut or another one of the options that I gave you, or we can, and then add this onto it. Or there's another thing here called steep shallow that I'm going to cover in a little bit. Steep shallow cut that actually combines both types of tool paths. Okay. So last but not least, for this part, I wanted to show you this thing called constant step over. This is a really nice solution for weird shaped parts like this. If you have a part that has like a kind of an organic outline and you want to follow that, the curves of the part, the surfaces kind of follow the outline of that part. So let's go ahead and we're going to hit constant step over, and we're going to say we're going to go from the outside in, click the model, and click do it. So there we go. So if we look in here, again, what it did was it used this outside shape, moved around that outside shape, and then offset it down into the middle of the part. If we look at this, you see this kind of weird spiral ghost line around. Really all that is where the tool goes from one cut to the next. So it comes here, it comes this way, and then comes in, does this cut, comes all the way around, then comes in, does this cut, and goes all the way on the part like that. This is a really nice tool path. Like I said, if you have something that's got kind of some weird shape and the surfaces kind of follow that shape around. So let's go ahead and talk about the last few more advanced options here, which are flats cut, intersections, steep shallow, and then I'll show you tool path splitter, and then the gouge checker, which is there's some pretty cool, powerful things here. Let's go ahead and just flip over to this model here. All right, so we're going to use this one. I'm going to show you flats cuts on this. This is a cavity or a concave part. All of the stuff that I'm showing you works on both concave and convex. Some of the tool paths work a little bit better on some parts than others. That's why I'm showing you the whole suite of options. So one thing I want to show you, like say for instance this part, let's say we roughed it out and then we came in here and we finished up these walls here with a little ball cutter and stuff. But I'm not able to get all these flat spots with my 3-axis. I mean, I could, but it's just kind of a pain in the neck. If I go in and just do a nice 3-axis tool path over this entire thing, these flat parts are going to have scallops on them. So what I want to do is I want to put a tool path on here that just addresses those flat parts. So I'm going to go ahead and use this 1/8" cutter, and we're going to go ahead and hit advanced. And we're going to hit flats cut. Okay. So I'm going to pick this model. I'll pick the whole thing. Let's turn that off. But what I don't want to select is these flats. I just want to address the flats inside of that model. So let's zoom it out a little bit so we can see it a little bit better. And let's go ahead and click do it. And there we go. So you can see that it just took all of those surfaces, figured out which surfaces were horizontal or planar surfaces, and put toolpath on it and finished those surfaces for me. So if I had put in a step over toolpath, whether it was a constant step over or a lace cut or an end curve flow, and I ended up with a bunch of scallops on these flats, I can just go in there with an end mill and then clean up those flat surfaces. This also works really well on the opposites of this, so on the core part of this, and I can show you that right now. Let's go ahead and open that guy up. Here we go. So let's just really quickly show the flats cuts on this one. So we come over here, let's go flats cut, and let's go ahead and make sure that that's correct. Go ahead and pick that whole model. Actually, you know what? I don't think I want to do any of those flats. Just unselect those. Let's move this over so we can see it, and click do it. Great, so there we go. So you can see that it went ahead and it just addressed all of those planar surfaces that the ball cutter probably left a pretty big scallop on. So this works really well with both cores and cavities. So using the same model, I want to go ahead and show this intersections. What intersections does is it cuts the areas where a near vertical or vertical wall hits a horizontal wall. So where those intersections happen, you're going to end up with a big scallop or a radius in there when you finish using a 3-axis cut with a ball mill. So what this does, this goes around and cleans everything back up. So let's go ahead and do intersections on this. Let's hit do it. And there we go. So we can see that it just went ahead and took that 1/8 inch end mill and just addressed those areas where you know that you have that intersection between a vertical or near vertical and horizontal surface. So this will clean up any little radius that's left in there from a ball mill. Another term for this is pencil milling. It's what in the industry term for it is. You'll see that a lot. So this is a pencil milling strategy. The other option you have for intersections is intersections rest. What this will do is only address radii that are left from a tool that you have here that's a reference tool. So let's say if I used a 1/4 inch cutter with an 1/8 inch radius on it, it would go through and just clean that up. So that's intersection. So let's go ahead. I'm going to move ahead and show steep shallow on this. Remember in the very beginning I said, what do we do when we want to have a tool path that projects down in the Z but also slices it horizontally so we can address the top surfaces and the side or vertical surfaces? That's what steep shallow does. So let's go ahead, and I'm just going to go ahead and select this whole model. And we're going to go ahead and hit steep shallow on this and click do it. There we go. So we can see that this part is actually what I would say is wrapped in toolpath. So if we look at a top view of this, we can see that it uses that constant step over or 3D pocketing for this toolpath and really finishes the top really well. But when we look at a side view of this, you can see that it also steps up in a nice even manner. So you can see that this is a really good way to, like I said, wrap toolpath around a part. This is really great for both cores and cavities or positive or negative parts. Even if you're not doing molds, you know, this is a really good solution for this. So let's go ahead and finish up showing you these two here, toolpath splitter and tool holder gouge checker. So let's go ahead and just dump these in the trash. We're going to go ahead and start over with this. All right. All right, so I'm going to start by just creating a really quick lace cut on this part. Step over 70 thou, that's fine. You know, it's just something that I just want to get a tool path on this. I'm going to go ahead, select the whole model, and click do it. Okay, there we go. So let's go ahead and take a look at this really quick. See how the tool path doesn't go all the way to the edge of those vertical walls? So why didn't it do that? It's, you know, looking at it. Well, if I look at my tool, the reason it didn't do it is, see, my tool is only sticking out a 1/2 inch. So Gibbs knows that tool holder is going to gouge if it goes down close. So this is as close as it can get using that tool holder. But I really want to use this to do the majority of the finishing on this, because it's a really good tool. It's sharp. You know, you don't want the tool sticking out too long. So what I want to do is I just want to come back and address these areas. Go ahead and close this out. These areas that didn't get cut. So what I did is I created another tool. It's basically the same diameter tool. It doesn't have to be, but it's got the longer reach on it. I'm going to take that. I'm going to drop it down into my process tree. Go ahead and do an advanced toolpath on that. So now you can see I have tool holder gouge checker on. So I'm going to go ahead and hit redo on this. There we go. So now we can see that the first tool path, if I just click this, I'm going to hit utility markers just so I can see that tool path. So you can see that's that first tool path that left that gap. We saw that before. And now we can see the second tool path just addresses those areas that were missed because of that holder not being able to, oops, move that up, that holder crashing in there. So we can see that's a really nice complete tool path that addresses the areas that are left after that gouge checker comes in. All right, so let's go ahead and talk real quick about the toolpath splitter. All right, so what I found when I was doing parts that were convex, so I want the tool to go up and over a part, I really like using an end mill, not a ball mill for that. There's a couple reasons. The biggest reason is the center of a ball mill doesn't actually cut, whereas the center of a flat cutter will cut. Also, as you're coming down an arc like this, if you use an end mill, it's actually cutting with that sharp corner of that end mill. So it's coming down and you're really getting a good bite. It's cutting, if you will, with the part that's supposed to be cutting. You don't have that kind of horizontal push that you get with a ball cutter. So it's everything's getting pushed up into the Z as you're coming down. There's a bunch of reasons. So for this one, I'm going to use this 1/8 inch cutter to go ahead and do a lace cut on this. One thing though, let me come down here, and I'm going to go ahead and just throw a lace cut on this. Pick the model and hit do it. Okay, so this is what the lace cut looks like, but that it's an 1/8 inch cutter, relatively is kind of small. If this was steel, I would really want to do this with a couple different tools. Maybe do it half and half, or split it into quarters and do some with one tool, switch that tool out, or put another tool in, and then go ahead and finish it up. That's what Tool Splitter does. So in order to use Tool Splitter, you have to make a tool in the next holder that's identical to the one before it. So I'm actually going to make a few of these. So now I have 4 tools that are identical. Okay. So now what I'm going to do is I'm going to come here and I'm going to take that next tool, and for my strategy I'm going to put toolpath splitter. You can see that everything's grayed out because it's going to use the same parameters as the first one. Now if I use 2, as you're going to see here in a second, it's going to split it in half. Okay, there we go. So it's kind of hard to see here, but we can see that there's 2 retracts. Again, I can use that utility markers. Let me just pick one, sorry about that, utility markers. So there, it's starting from the bottom up. So there's the first tool path. And then there's that second tool path. Now watch what happens as I come through and I add those other tools in there. So let's say toolpath splitter, and last but not least, number 7, toolpath splitter. Now remember, they have to be the same geometry tools in order for this to work. So let's go ahead and hit redo on this. All right, so there we go. So again, let's go ahead and check this out. We'll start at the top now. Let's say utility markers. So there's that quarter part. There's the next quarter. There's the next quarter. Each one of these you can see tool 4, tool 5, tool 6, tool 7. So if I really needed, it was really important for me to have sharp tools throughout this whole finishing process. This is a really great way to do it. In this way, what I've done in the past is, okay, I have to change the tool. I hit pause on the machine. If your machine's able to pause in the middle of the tool path, take it out, replace it, offset, change the offset in the controller, put it back in. It's time consuming. This way you can put in, 4 tools, have all of your offset heights set inside of your machine, hit go, it'll just do it. Lights out machining, you don't have to worry about changing the tool. This is a really helpful thing when it comes to finishing molds. Thank you for watching. If you have any questions, please feel free, contact your local reseller, or you can contact GibbsCAM directly at the information on your screen. Thank you so much.